Hello students. This is the video I'm making. It's almost night, 11 o'clock, and I'm still thought of making this video to some of you to help. And also as a study guide for the exam one. This is quiz three. Quiz three. I will walk through all the problems here. The first problem is find the coordinates of the polynomial after indicated translation. Now you remember translation is xy and to x plus h and y plus k. So what is that? H is decide the left and the right, and this decides the up and down. What it does is you need to take care of this. This means 6 units to the left, so you have to subtract. H is you have to subtract the each of this. So so that means the first one 6 and 4, right? So 6 4 and 4 and 1 and 8 and 1. All you do is because it's moving to the left, you'll have to subtract, subtract 4 here. So this 4 you have to subtract. That means you minus 4 and minus 4. Sorry, not that. So each of those down you subtract minus 4 because you're going on the left side. Okay. And then the second part is 3 units down. That means the k is minus 3. This is minus 4. That means you're going to the left, so minus 4. And this is, so in this case, you are subtracting 3 and you are getting the answer. So hope this will help to get the answer. This is 6 1. That is 0 minus 2. And this will be 4 minus 2. Let's move on to the second question. So what is the meaning of question number 2 is if a function is odd function, then what type of symmetry does the graph f has? So what is the meaning of f is, that means if this is the graph, like they say, this is the graph, and what does the odd function basically means? There is a the graph reflects over the origin. So if whatever that graph that you see is goes something like this, say, same thing but reflection uh, over the origin. It means if there is a point, let's say this is 4 and 3. So if there is a 4 and 3, the reflected point will be on the other side as negative 4 and uh, negative 3. So this becomes negative 4 and negative 3. So the graph, the function f has a symmetry with respect to the origin. So that's the understanding of odd function, or its reflection over the, or it also is rotated 180 degrees around the fixed point, or the origin here is rotated 180 and you get back the same graph. Just an example here, you can see this graph is f of x is a cube root of x, and clearly if you, this is an odd function because it is every point, any point on this, whatever the point, if a is b is a point on the graph, then also minus a minus b is a point of the graph because it is a reflection over the point. You see this graph reflects, or you can just rotate this 180 degrees in the counterclockwise direction and you get back the same graph. That's all that means. Let's go to question number 3. This graph says if a function is given and the indicated transformations are applied here, write the equation. So this is given to you. That means there is a absolute value function which is this one, the V shape, and it said shift to the left. So that means you want to create another function which is just transpose of this one. Because it's moving to the left, you have to write x plus 6 and it shifts 9 down, so you go minus 9. So basically it is x minus h and plus k. So this h that you see is going down to the left is h equals minus 6 and the k is minus 9. But then because of this minus and this minus, they become positive. So usually we remember directly we remember that anything inside the parenthesis here, you do the opposite. So if it is plus 6, it is minus 6. So because it is going to the left, you just put plus 6. So that's all. It is a shortcut to remember. Next. Question number 4 is if you're given this one and you're supposed to reflect over the y-axis. Now, what is this, first of all, is reflection over the y-axis, the new one, gx, will be, you have to just change the x has to be changed to minus x. So that's like how you do the reflection over the y-axis, okay? And then you shift it 6 units up, upwards. That means you are adding plus 6, so because you're going up. So what is this graph is the fourth root of x. So what is this fourth root of x? Actually is the graph something like this. Maybe this is the graph which is fourth root of x. And all you do is first reflect. So this goes this way. So if this is fourth root of x, that becomes fourth root of minus x. You can see the domain is less than 0. And then you're supposed to take it 6 up. So 1, 2, 3, 4, 5, 6. So it goes like this and you're done. So that's the understanding of this fourth root of x. Now in this case question is you are given the blue graph is the main graph. This is the fx graph which is absolute value of x. And you find the red is the graph that we need to figure out what's happening here. And you can see this point clearly it is a there is a vertical stretch. So this is the absolute value function stretch vertically. So you can pick a point here. You can see this is 2 comma 2 and I can take this point is so the x coordinate is the same but the y coordinate is c and you can see that's the ratio 6 over 2 which is 3. It means this point is multiply this 2, so it's like this 2 multiplies by how much, or you can say what multiplies to 2 to get 6, and you can see just divide by 2 and that's how the k or uh, scale factor. This time we write a equals 3 scale factor. So the graph gx, the red graph is the scale is graph obtained from fx, which is after vertically stretched by scale factor of 3. That's all it is. So your answer this will be 3 times whatever the beginning. That's it, and you're done. Or or it could be also suppose what if this graph or another graph was shown this way. See, this could be another graph. Then you'll see this 2 becomes 1. See, so you make it half of that. So it means it will be half of that. So take note of this. Because if you take this point, it is 2, 1, right? So, so what multiplies 2? So this is 2, 2. So what multiplies 2 to get 1? And you can say half of 2 is 1. Okay, so this is question number, I think it is 6 or 5. You can check it out. So this is the original absolute value function. So you can see, you want to know what's going on here. And clearly you can see this dot has moved here, right? And also it's reflected over the y-axis. The first thing you do is, I'm going to reflect this over the x-axis. So that will be the new function square root of minus x. And this square root of this part, then you move 1, 2, 3, 4, and 5. So that means once you reflect over the y-axis, so this is reflection over the y-axis, and then you shift 5 units to the left and get the answer. So what does this mean? 5 units to the left inside this one. you do actually plus 5. That's it. You're done. That's the answer you wanted. And it's the square root of x. Actually, it is minus of minus 5 because you're moving to the left. Question number 7 says you're given the blue color graph. This is the one. And this blue graph is a parabola. So this is x square, right? So what must have happened to this is first you reflect. So I can write this changes to maybe the new function will be minus of x square. So I'll put a parenthesis. So yeah, because this is the new one. That means you first reflect. Then you move 1, 2, 3, 3. So that means this whole thing square and like minus 3. So shifting 3 units to the right. And then so it will be something like this. See? And then it goes 1 and 2. So you have to write plus 2 outside. So this is the new function, which means you first reflect. So this minus is first reflect over the x-axis, then move shift 3 units to the right, and then you 2 units up. Or you could also say you first move 3 units to the right. Another way to do is directly saying, okay, you first take this blue one, take it exact this way. So you're moving, so you do to the right, 3 units to the right. Then you reflect, so then put a minus, and then you take it up. So that means plus 2 and you're done. Use this, this is the absolute value function. See, the original function is this one. This is the original absolute value function. What has happened, you can clearly see. You have to first reflect. So that's what you do. So that means you reflect and then you go 1, 2, and 3 to the left. So that means inside you do plus 3 and you're done. That's all they're asking you. So this answer is minus x plus 3. Question number 9. Again, they're asking you, okay, this is the original graph, which is square root of x. And you can clearly see it went down by 7. So that's like, or you can see it went to the left by 2 units. So you do x plus 2, and then it went down. So first it goes uh, 2 units to the left, and then you go 7 down. So you write minus 7, and that's the new equation. Okay. One more thing I want you to be very careful here. The next question is the meaning of. So let's see. Let me use this graph. So use the same grid, this one, okay, and this is the original graph. So this is the original graph, which is square root of x. Now, what is the meaning of minus x? Basically means it reflects over the. So it's something like this. So take note of this. So this thing, right? Minus x plus 2. But what is the meaning of this minus x plus 3? See, now you have to be very careful here. What basically means, uh, this doesn't mean that, does not mean you go mean 3 left. No, this is, it's because of this minus, we do just the opposite. That means we go 3 right. So be careful. Let's say and why it is. So if you see this goes 1, 2, and 3. It goes this way. You can see the reason is, you can see the inside minus x plus 3 has to be greater than equal to 0, and you subtract 3 both sides, and you get minus x is greater than minus 3, and then divide by minus 1, and you can see x is less. You have to switch the inequality sign because you're dividing by minus 1, and it becomes 3. So the domain is until plus 3. So there it is. This is plus 3. So this is the right graph. So that's how, or you can also write this part is square root of minus x plus 3, which is same as square root of minus x and minus 3. And you can use the same idea and say, okay, all you do is first you reflect. See this part? So this is the original. First you reflect this way and then move to the right. One, two, three. And then you got this one. And that's how it is. So I think this is the B. So the original graph. So this is the original graph, right? So that's square root of x. So what I'm going to do is first let me reflect it. So that means I'll do this one minus x. I'll put it this way. So that means it's going this way, right? That's this part, whatever I showed. And then I want to move it because this point is here, so I want to move it 3 to the right. So all I do is x minus 3. That means your new graph will be this one, right? This is the graph. And after that, I'll do the next is this stays the same, and I want to flip it over the x-axis. That means I'll put minus out. So that means this is the graph. Okay. And finally from here, you go one, I think it is two, one, two, three, four, and five. So you're going five down. So that means it is root of minus x and minus 3 and minus 5. But this could be also written as minus x plus 3 and minus 5. So this is the final answer. So a lot of confusion here is, remember, you had this for a second, you reflect over the y-axis, then shift it to the right three places, then reflect over the x-axis, and then move or shift 5 minutes to the shift 5 minutes down, and that's how you finish the problem. I hope that happens. Question number 10 is write down the what. So this is absolute value. So this is absolute. Okay. Then, but shifted 16 units up and reflected. So up basically means this is uh, but then I want you to do the first reflection over the x-axis. So that what is that means is you just put minus x, right? So minus x, and then you shift up. So always do reflection first. If there is any reflection, it's all better to do that first, and then 16 up. So plus 16, and you're done. So this is all you're supposed to write. But just knowing that you know the graph, look at this graph, and you can see that is a cubic, right? So what is that basically means? You have to know that the cubic graph always looks like this. This is a cubic graph, okay? But then this time, this is down, up, but the one that they gave is up, down. That means if the original one is x cube, let's say this is the original one, but then if I do minus x cube, it means this graph, whatever that shows here, becomes something like this. See, this goes down. And then all you have to do is this point moves here. And what is that point is? This is like 2, and that is again 2, I think. Hmm? Hold on. Yeah, so that point is 2, 2. That means you move 1, 2, and then you go 1, 2. So this graph, which is first you reflect over the y-axis, okay, and sorry, I made a slight mistake here. You do, yeah, basically it is you are doing over the x-axis. Yeah, so first you put reflect over the x-axis, so you get this graph, and then you move 2 units to the right, so it goes this way, and then you move up. So this is the final one, which you clearly see there. So the answer is this for mine. Hope that Makes sense? So this is the graph. First reflect over the x-axis, and then you move to the right and go up. It also means it is a you could reflect over the y-axis. So if you want to write reflection over the y-axis here, also you can write if the original function is, let's see, if f of x is x cubed, and you can want to reflect over the x-axis of the new one, that be px, I'll put, and that is minus x cubed. See, which is same as minus x cubed. So that's the px in between graph, and then you shift 2 units to the right. So basically, if this is the graph, you first reflect over the y-axis, and then you move this side, and then you go up. Okay, so hope that helps. So what is this graph? Now remember the original graph here is, so if this is the full grid and this is the origin, if this is the graph of square root of x, so what must have happened is you just reflected over the first you reflected over the y-axis like this. See? So that means if this is the first step, then the next step is you write square root of minus x. And then you go 1, 2, 3 down. That means minus x minus 3, and you're done. That's it. That's all you're supposed to do. Okay, what this means is there is a function which is increasing on the interval this and this, and then it is decreasing in this interval. Okay, the question is what happens to the function? So let's put it like this. I want to make a table so that you really get this part. See, okay. So the original function is f of x, okay, and you want to know increasing, and then I'll write decreasing. And the one that shows is it says it's increasing in minus infinity, minus 6, and then from 9 to plus infinity, and it is decreasing here from minus 6 to 9. Okay. Now, a lot of question can be made out of this, and the first one is if you create a function gx, and I could write gx is, let's say, uh 2 of f of x. Okay, what's happening is the y coordinate will change. See, this minus 6 maybe that will change, or this 9 will change. Okay, but this 9 and this minus 6, they will stay the same. So by multiplying two outside, or also even for if you had to move up and down, let's say h of x, another function I write is f of x and minus 3. Let's say that means again you're going to change this numbers 9, but the x will not change. So no matter what you write here, this function, or shifting up or down, or by multiplying scale factor 2, does not, of course, if it is positive, then you have to be very careful if it is negative. Uh, so this does not affect. So this stays the same, minus infinity, minus 6, and 9 and plus infinity. And this stays the same if you shifting up and down does not change. But px, I'll make a px here, which is let's say minus of f of x. So that means what does this do is it changes increasing become decreasing and decreasing become increasing. That means this will go here minus 6, 9, and this will go right here, which is minus infinity and minus 6. And the other one is 9 and plus infinity. So the reason is if I want to graph, of course, what is this graph is minus 6 to 9, right? So let me say minus 6 to 9. minus infinity to minus 6 increases, and then again 9. So minus infinity to minus 6. So 1, 2, 3, 4, 5, 6, minus 6. So maybe it's increasing. See, this is increasing until here. And then again from increasing from 9 to infinity. So until 9 it goes down, maybe 1, 2, 3, 4, 5, 6, 7, 8, 9. So it goes down and then again to infinity. See, that's all that means. It is this is increasing, then decreasing, and then increasing. Now, if I so the main point are this point. So these points are the main plus 6 and plus 9. So this point, if there is a new function gx and you want to write the old one and then you want to add 3 or maybe you want to subtract 5. So what will happen? Either the graph will go something like this or maybe it will go this way. So, but increasing, decreasing will remain the same. So that's what all I wanted to show. And how does uh, uh, so what is the meaning of suppose what is the meaning of px is minus of f of x? What's happening here is this increasing. Okay, the way I have done this will reflect down here. Okay, and it will go. So it's something like say it goes till here. This will reflect here. So instead of increasing here, now it will decrease that. And then again, instead of decreasing, it will increase here. This is increasing. And then finally, instead of increasing, this will go like something like this. There you go. So I hope that makes sense. And what is the meaning of that? All you do is just change. So this decreasing this part, this intervals will go right here, and this interval minus 6 will go right here. Done. So I hope that takes care. Then next is okay. The difficult part is now. Let's see if it is okay. This is again is qx is where f of x minus, let's say x minus 3. So what that means is you're going. So if it is x minus 3, it means the graph is moving to the right, 3 units to the right. So all you do is this thing, see minus infinity, if you add 3, it doesn't change, so it will stay the same. Minus 6 stays the same, but this 9, you have to add 3, so it becomes 9, 10, 11, 12, and to plus infinity. And this minus 6 will now you add 3, so it becomes minus 3 and 9. So what it means if you go 3, this is the graph, right? And let's take this graph and understand clearly what I'm saying is, so this is the original graph, and I'm saying the graph shift 3 units to the right, so this is minus 3. So what's happening here is this goes something like this, see? So this way, so it goes this way. Then this goes 9, 10, 11, 12. See this one? So goes till here. And then again goes up like this. So see, everything goes 3 units to the right. And that's all you're supposed to do here. And you're adding 3 to the x coordinate. So hope that helps. And finally, what about okay, even if I put plus 5 here, if instead of plus this, I could change this to uh plus 5. So that means you subtract 5. That means uh, from minus infinity you take away 5. It will stay the same, but this 9 minus 5 will be 4, and then infinity will stay the same, and this minus 6 You subtract 5, that minus 6 and minus 5 will be minus 11. And that's how you do this. Okay. And let's write Rx is the last one. What if it is uh, f of minus of x? Now this is a little tricky part, so you have to be very careful here because what that means, it reflects over the, this means reflection over the over y-axis, right? You see this graph. So this is the original graph that you see. Oh, sorry, made a mistake. So the original graph was 9, and then this was the original. Now what's happening is, because this will reflect, this minus with 6 will go reflect to minus 6 right here. So this doesn't look like nice graph, because this looks like 9 should have been somewhere here. So let me take this off, and maybe this is like minus 9 here, and then so decreases, and then this is the thing, right? So what I'm trying to say is, when you reflect, that will be minus 9 right here. This 9, which is minus, sorry, plus 9 right now, this will shift somewhere here. See, it will shift here. Okay, and this one, this red, will move here. So instead of this one going here, decreasing, see, this part is going down here. So this will be going uh, from minus 6 to 9. It was decreasing, but when you reflect, it will increase. Only thing, I put this wrong. So this dot is be somewhere here maybe, and that's how it is going to increase here. See, this is going to so from minus 9 till 6 here. See, so this minus 6 changes. So basically, it's increasing in minus 9 and 6. What's happening is, it was decreasing. The original one was decreasing from minus, so it was decreasing from minus the red color until 9. It was decreasing, but because of the reflection over the x-axis, instead of decreasing, it became now the blue one, which is increasing. So here it is. So, but then how does this change? Here it is minus 9. So that's why I have minus 9 and 6. So this is plus. So basically, this minus 6 becomes plus 6. It switches to the y coordinate, and this plus 9 becomes minus 9 here. Okay, so that's all. So basically, what I'm trying to say is in order to figure out what goes here, all you do is whatever this. So remember, this was, let me write that. So the original the function was minus infinity and minus 6, and then 9 to infinity, and this was minus 6 to 9 decreases. So this one, this thing, you go down and you just write the op. So if it is plus here, so you write minus 9 and plus 6. So it is, instead of decreasing, it is now increasing. And this thing will go down, but still you have to switch the sign. So instead of minus 6, so from minus 6, or I'll start with this first, because infinity plus infinity becomes minus infinity until minus 9. Okay, and then again, this opposite of minus 6 plus 6. So plus 6 to, and opposite of minus infinity plus infinity. And this is a little confusing, and I hope makes sense to you there. Or you can remember it another way is if I put Yeah, I hope this helps. Okay, I hope this question we did in the class last 1 week, so I don't think I should show you. These are very easy questions. I'm expecting you to do it yourself. The only thing I want to make sure, this is the one I want to show, is the square. Let's see, the radius is half of this. So the question now 18 is a square concrete foundation is prepared as a base, and you can see the base for a cylindrical tank. So now this is a cylindrical tank, and you want to create a composition of two functions. The first function is the radius function. Okay, so I'll call it as g of x, and that is the radius function, so r. And you can clearly see that it depends on what is the side length of the square here. So this becomes, so the radius is the function of side length, so it is x half of it, right? But then the area of the square, the f function, and I call it as function of the radius, and that is I call lower a. I use lower a to show the area of the square when it is, it depends on the radius is pi r square, and then you can have, and then of course the one that you give is they directly give you this a, so I'm going to write a. So a, instead of area function, this a is depending on the radius, and now I'm going to use the f circle g of x, and that is f of g of x. So your gx is x by 2, f of x by 2. So this is the radius, and f, what does f do is you will do pi and x by 2 square, and you get pi x square over 4. And you're done. So the second question is here, this should be for this one. What it means is this represents the area of the circular base of the tank on the square founded with a side length x. So this is suppose the answer. This problem is asking what is f g of 6. So you go for g for x. So when this is x is 6, then you can say this gx takes all the way till here 4. So g of 6 is, so this is g of x is 4, and then you take the f of this 4. So you go from here, you go all the way to 4, and then you say f takes 5. That's how this problem. The graph is given. What is the rate of change? Is just a slope rise over run, and you can see you go 2 up. Be careful, you don't go 2. Yeah, yeah, you go 2 up, and you go 4 right. So 2 divided by 4 gives you half, and you can find the slope ax equals b, y-intercept form. The a becomes the slope, which is you go 2 up and 4 down, so it is 2 divided by 4. And this is where y-intercepts, and then that's minus 2, and you're done. And then this is a function gives you the rate of change, is at what rate is the water is flowing in the pond, and that's given, that's the slope. And starting there was 400, so you see it's just multiplying this by, be careful with the symbol that is used. This is t, so you'll have to write here 14t and then plus t, and then here you have to work out, you plug in 1560 in the left side, and how long does it take, means you'll have to subtract 400 and then divide by 14, and you get the answer in time. I hope this will help.